All right, here we go. The first three problems, they are asking you to find all zeros, okay? So this is just a matter of factoring. We're going to factor to get all of our answers. And when we factor, if you guys look at this, you've got 4 terms. They don't have anything in common. So when there's 4 terms and nothing in common, typically we go and use like the grouping method to factor. So you want to do GCF for the first 2. So what do these 2 have in common? They have x what in common? X squared in common. And then inside the parentheses, what would we have left?
X plus 3.
Yep, x plus 3, good. Okay, now after you do that, like you really don't need to even look at those first 2 terms anymore. We just want to shift over to the next 2. Bring that minus sign down, and then 2 and 6 are both divisible by 2. And if you've done this correctly, when you divide these 2 by -2, you should end up with x plus 3 again. So -2x divided by -2 would give us x, and -6 divided by -2 would give us positive 3. Okay? So then, with grouping, the GCFs, so your x squared minus 2 go together in one set of parentheses. And then the parentheses that they had in common, the x plus 3, that's your other set of parentheses. So once you have those 2 sets of parentheses, that's where you break them apart and you solve each one individually. The x plus 3, you guys, I mean, most of you in here usually just give me the answer to that one. That would be x equals what? -3. Now the other one, I would not suggest trying to do this one in your head, especially because it has the x squared. So I would write it out as x squared minus 2 equals 0. And then we're going to solve that. So we're going to start by adding 2 to both sides, giving us x squared equals 2. And then how do we get rid of a squared? You take the square root. Yep. Now look, when you guys take the square root, first of all, we don't know the square root of 2. So we leave it as the square root of 2. But what has to go in front of it?
The I.
No. To show that there are 2 answers. What do we put? What symbol? Plus and minus. You put the plus minus symbol because when you take square roots, technically they can be positive or negative. And when you look at that, now you can see that there are 3 solutions. There's positive square root of 2, negative square root of 2, and -3. And then that one's done. Okay, now how about the second one? What do those 2 have in common? They both have an x in common, and when you factor out an x, what does that leave on the inside? X squared minus 9. Okay, so anytime you have some form of x, meaning like if it's x squared, if it's 2x, -3x, as long as there's just an x outside, one of our answers automatically is 0, because you would set that piece equal to 0, and then there, you know, it's already solved. This one over here, you know, we're going to have to do just like what we did on this one over here. We're going to take x squared minus 9, set it equal to 0, and then we'll solve it. So what do I do first? Add 9. So you get x squared equals 9. Take the square root. What is the square root of 9? Since we know the square root of 9, we're going to make it positive or negative 3. Okay, good job. Then the third one, what do all three terms have in common? They all have an x in common. So we're going to bring out an x. And if we get rid of an x from each term, our exponents just decrease, right? So like all your terms will stay the same, but your exponent will become one less. So you'd have x squared minus 5x plus 4. And then we can do an asterisk for that to get our two sets of parentheses. So we have a positive 4 and a negative 5. What two numbers? Yep, negative 4 and negative 1. So now remember, those are the two sets of parentheses. Those are not your like final answers for x. And if you guys could look up at the board, this will be one answer, two answers, three answers. We'll have three answers and they're all going to be different. So like when x is by itself, you've got a 0. What would this one equal? Yep. So there are your three answers. Okay, so actually I've got the test right here in front of me. So your test tomorrow, problems 1 and 2 are just like this. Problem 1 is a grouping problem, and problem 2 is one like this where you'll factor out an x and it'll be a difference of squares. So this is just like number 1 on the test, and this is just like number 2 on the test. So I'll try to write that as we go, just so you guys have an idea. Yeah, so I'll tell you this. The one that we're getting ready to do on number 4, it says determine the zeros and sketch the graph. That's what you have to do on number 3 of your test, but it looks like the one on your test looks like this. It looks like the one we just factored. It does not look like a grouping one. So number 3 on your test is basically a combination of number 3 and number 4, if that makes sense. It's going to be this kind for you to factor, but then you'll have to sketch it. We went through the sketches yesterday, so you'll see once I go through it. Okay, so the first thing we need to do is we need to get this thing factored. And again, when you've got 4 terms like this and they don't have anything in common, we're going to group those. So we're going to use grouping, just like we did on problem 1. I'm going to do that over here. Okay, so x to the third and 5x squared have the x squared in common. And then when we factor that out, you'd have x minus 5 left. Then this minus sign, I'd put right here. And then 4 and 20 are both divisible by 4, so we're going to bring that out. And in parentheses, we would be taking negative 4x divided by negative 4, which is x, and positive 20 divided by negative 4, which is negative 5. All right, so the two sets of parentheses, remember these two go together. So x squared minus 4, and then the x minus 5 is our other set. This one, you guys can just give me the answer. X equals what?
5.
Yep, that one would be x equals 5. Now this one over here, anytime it's more than a one-step equation, I always suggest that you write it out. Just make it a little bit easier on yourself. So I would add 4 to both sides, and then we'll take the square root. But just don't forget, you have to do the plus minus. Okay. So once we get our zeros, those answers, those 3 answers that we have, those are the 3 x-intercepts. Okay, so these are the x-intercepts. So what you're going to do is you're going to put a dot at 2, 5, and -2. So -2, 2, and 5. Those are the 3 answers that we just got. Now we need to talk about what we did yesterday. So remember yesterday, if it was an odd exponent, the ends did what?
They went opposite ways.
Opposite. And then if it was positive out here, so like in front of the x cubed, it's positive, right? That meant typically the left side should be decreasing, the right side should be increasing. So this is what we know. This side over here should be facing down. This side up here should be facing up. So since it's a sketch, watch me. All we have to do is make sure we start down, and you guys want to just curve around to where you end up crossing all 3 of those points. And as long as you start low and end high, you'll earn your points for the sketch.
So if it's positive over here, in the front of the square, it means that this side goes down.
Yep. And if it were negative out front, it would be switched. It'd start high and end low. Yep. Okay, and then whenever you guys are ready, just go ahead and turn the page to the next problem. Number 5 and number 6, that's what we did yesterday. Now, look, there is only one of these on your test tomorrow. So there's 2 on the practice test, but there's only 1 on your actual test. And the one on your actual test is problem number 4. Number 4 on your test, the directions say, like, determine the end behavior. Okay, so look at the picture. Down on this side, as x approaches negative infinity, y approaches what? Since it's going down. Yep. Okay, so basically what we're doing is we're saying as we go left, what is my y value doing? So as I go this way, the y is decreasing. So that's why it's negative infinity. As my x increases, as my x goes to the right, what is y doing? Which means it's going towards positive infinity. Now on number 6, see how they're both facing down? So wouldn't they both be going towards negative infinity? Okay, so then you guys just put negative infinity on there. So like I said, there were 2 on the review like this, but on your test there's only 1. Pretty simple one. All right, number 7 on the review matches number 5. on your test. It says, state the possible zeros. So we're going to do possible zeros first, and then we're going to find the actual zeros. So let me just remind you, the possible zeros, that's when we do the P over Q, and we're going to have lots of like positives and negatives there. But then the actual ones, we'll use synthetic division to like find the new quadratic, we'll factor it, and we'll get our answers. Okay, so the P, this is P right here. All the factors of 2 go up top. So what are the two numbers that multiply to make 2?
Plus and minus 1.
Plus and minus 1.
Plus and minus 2.
And plus and minus 2. Those are the two numbers that would multiply together to make 2. 1 and 2. You just have to include the plus and the minus. Okay, now on the bottom, Q are the factors of 5. So that'd be plus or minus 1 and plus or minus 5. Okay, so to write out the possible solutions, or the possible zeros, watch. Okay, what I like to do is I'm going to ignore this 2 up top. I just do, like, look, 1 divided by 1 would give us 1, right? You just have to include the plus minus. And then 1 divided by 5, isn't that just 1/5?
Yeah.
So you could have plus or minus 1/5. Okay, then we're going to shift over. And instead of looking at the 1 up top, we're going to look at the 2 up top. And I'm going to do 2 divided by 1. That's just 2, so plus or minus 2. And then we do the 2 over the 5, which is 2/5. So plus or minus 2/5. Okay, so those are your possible solutions. So if I look at that, there's 2, 4, 6, 8. 8 possible solutions. Now we know very well that there are not 8 answers to this problem. We are now going to determine the actual answers. And what we do, okay, so let's see how much you guys remember. We're going to do synthetic division of this right here. So there are 1, 2, 3, 4 terms. So when you draw your box for synthetic division, there are always 3 rows. And the number of columns come from how many terms there were. So since there were 4 terms, we're doing 4 columns. The numbers here, the 5, 4, negative 11, and 2, that's what goes up top. And then remember out here, we always start with positive 1. And the hope is that if we use positive 1, our remainder over here will be 0. I mean, that's what we're looking for. And if positive 1 doesn't work, negative 1 should work. So let's try positive 1 and see what happens. Okay, so here's the process. Whatever number is at the bottom gets multiplied by this. So 5 times 1 is 5. And then add up and down, which is 9. And then you multiply the bottom number, which is 9, times the 1 out front, giving us 9. And then you add negative 11 plus 9.
Negative 2.
Negative 2. And then the bottom number, negative 2, times the 1 is negative 2. And look, we get 0. So that's great, because now we don't have to try negative 1. We just know that the 1 is one of our answers. So look, this is what I would want you guys to do. Over here, for the actual answers, this one works, right? The 1, because we just tried 1. So automatically we know x can equal 1. Now to find the other ones,
We do the
hang on, just watch this. You need to use this bottom row to write your new function. So remember, this would be 5x squared plus 9x minus 2 equals 0. So we're using that bottom row to write our new function, and this is the function we do the asterisk for.
How do you get all the
Okay, so the original problem was x cubed. Your answer here is always 1 less than that. So instead of starting with x cubed, you start with x squared. And you just work your way down. Okay, so look, up top, if we do 5 times negative 2, that's negative 10 up top. 9 at the bottom. And the sides, instead of 1x's are 5x's. Can you guys all see that okay? Here, I'll zoom in, but two numbers that multiply to give you negative 10, but add to give you 9.
Negative 10 and 1.
How about positive 10 and negative 1? Just because, you know, you want the bigger number to match the bottom. One side should reduce, so like 5x minus 1, not going to reduce, right? But the other side, the 5x plus 10 will. If you divide by 5, it'd be x plus 2. Yep. You're okay. This problem is a lot of work. It's not difficult work, it's just a lot.
I know, I'm recovering from a fever dream, so.
Okay, so the x plus 2 would give us
Negative
x equals negative 2, right? Here, let me shrink this back down so you guys can actually see here. Because then, look, all of my actual answers, that's one of the actual answers too. So we had 1, we have negative 2. This one right here, I would actually work out because it's not just a one step. Like you can't tell me that this would give me a positive 1. No, it wouldn't. I'm going to add 1 to get positive 1, but then don't I still have to divide by 5? Yeah, so 5x equals 1, and then I'll divide by 5. So it looks like the other answer is 1/5. So all of these, 1, negative 2, and 1/5 are my actual roots. There's a lot. Okay. Let me look here. There is a multiplication problem on your test. So this one right here, number 8, the one multiplication problem on your test is number 7. Okay, so if you have a fraction times another fraction, and it says simplify and state the excluded values. What that means is anywhere where you can factor, we need to factor. So like, can you change p plus 3? No. Can you change p plus 10? No. So this left fraction is going to stay the same. Nothing there changes. But the other fraction, we can definitely factor out some stuff. Like up top, what are 7 and 28 both divisible by?
7.
And not only 7, but don't they both have a p squared?
Yes.
And when you take out a 7p squared from each, that leaves p plus 4. Now on the bottom,
What is that?
yeah, you're trying to find the 12 and the 7 for the bottom.
Uh,
3 and 4?
yeah.
Now, look, before I do anything else, I'm going to put my restrictions because it says state the excluded values. So let's talk about this real quick. If you look at this whole bottom, there are 3 numbers that P could not be. -10, -3, and -4, right? Because any of those numbers would make the denominator 0, and you can never have that. So P is not allowed to be -10, -3, or -4. And those restrictions are important on this one just because we're not really solving anything, we're just simplifying. So you need to make sure you list out what numbers they couldn't be. And then look, here comes the fun part. This is the best part. We start getting to cancel stuff out. So like there's a P plus 3 up top and on bottom, so they're gone. There's a P plus 4 up top and bottom, they're gone. So up top, the only thing we have is 7P squared. And on the bottom, the only thing we have is P plus 10. Now that problem is done. We factored wherever we could, and then you just cross out whatever they have in common up top and on the bottom. Now I don't think there's one on your test like number 9 where it's just 1 and 1, like just one fraction, but we're still going to do it. We're still going to just practice it because it's good for factoring. The top would be an asterisk problem, so we'd have a 90 and a -19. And I don't know about you guys. I know you have a factor sheet and you could use it, but the minute I hear a number end in 0, I automatically think 10. So like I was thinking 10 times 9. Well, will 10 and 9 make 19? Yeah, as long as they're both negative, right? Yeah, so I mean like, yes, you could have used your factor sheet and you would have figured that out anyway. But the ones that end in 0 sometimes are a little bit easier to figure out. So that's your numerator. As far as the denominator goes, that's just a GCF. But they're both divisible by 10, right? So we have to put the 10 out front, and then it's x minus 10. Yeah, you always have to put whatever they have in common, you've got to put it out front. So x could not equal positive 10. Yeah, that's the only restriction we have. That's the restriction. And then we could go ahead and cross out x minus 10, right?
Which just leaves x minus
I'm going to put these here for now so they're out of my way. All right, everybody have those written down? Okay, turn your page. Let's see, there's another multiplication one and a division. So another multiplication one, I mean, that still goes along with number 7. This is just another practice for number 7 on your test. And then the division problem on your test is number 9. There tends to always be more on the review than there is on your actual test because I want to give you a little bit more practice with it. But for this one, obviously we can't factor here, right? Mm-hmm. The 2's are going to stay for now. I mean, eventually they'll cross each other out, but let's just rewrite them for now. And then aren't both of these just GCF problems? Yeah, because they don't even have an n squared, so it's not a quadratic. Divisible by 6 on both of them? You mean n? If you divide both of these by 6, you get n plus 1. And then up here, if you divide both of those by 6, it'd be n minus 8. There's only one restriction. N could not equal negative 1. And the 6s? Yep. Okay, then our division problem. Number 11 for the division, you end up doing this basically just like you do the multiplication. We're going to factor wherever we can. We do keep, change, flip. Okay, that's the only difference. We want to factor here and here. We're going to change this to multiplication, and then we have to flip this side. Now, if there was something over here that needed factored, we'd have to factor it, but neither one of those factored. I will tell you on your test, this side, there are terms that need factored, but you have to remember not only factor it, don't forget to flip it. So I'm going to go ahead, and I'm just going to go ahead and flip that side while I'm thinking about it. And I went ahead and changed that to a multiplication symbol. For us right now, all the work is going to happen over here on the left side. So the top, that's an asterisk. The bottom is GCF. I'm going to just draw my asterisk over here so I'm not wasting space. There'd be a negative 36 and a positive 5. Let's see. 9 and 4. Positive 9, negative 4. So P plus 9 and P minus 4. For the GCF on the bottom, they're both divisible by 7 and P squared. Leaving P plus 9 on the inside. Hang on, let me do my restrictions real quick. My restrictions, this could not be negative 9. And then this one here couldn't be 0. Oh, you guys can't see that, can you? There you go.
Is it just by what the denominator can be?
Yes, because the denominators are never allowed to be 0. Numerators can be anything. It's just the denominators that matter for their restrictions. Okay, so then it's like, okay, here's P plus 9, 7P squared, 7P squared. P minus 4 over 4. That would be your final answer. All right. Now, I already wrote down here what problems they match on your test, so you guys might want to go ahead and get that on there. 12 and 13 are both addition, so that's like number 8 on your test. And then number 14 is subtraction, and that's like number 10 on your test. So both of these could help you with number 8, and then this one will help you with number 10. All right. I personally think that these are some of the hardest problems because we have to get common denominators, and sometimes the common denominators can be a little tricky. This, I want you guys to look, this denominator right here, couldn't I change that to 2 times b minus 2? Like, couldn't I factor out a 2 and do GCF? Bless you.
Thank you.
This right here using GCF can become 2 times b minus 2. So if I'm trying to, bless you, if I'm trying to establish a common denominator for these two fractions, look, whatever they have in common, we're definitely going to use. So we definitely have to have b minus 2 as part of it. But then whatever they don't have in common, like this 2 that we pulled out, we also have to include that. So that right there is your common denominator. And what you're supposed to do at that point is you are supposed to take this, and put it up top here and put it up top here. And hopefully something will cancel, or all of it will cancel. So like if you write them both up there, look, you might want to look while I'm doing this and then just fill in the rest. This b minus 2 would cancel. Wait a minute. Wait, stop. I just messed up. I was thinking we were doing the equations. I got to fix that. We just changed our denominators to this. Put that on there. I was a step ahead. I am so sorry for that. Yeah, this really didn't cross out. Just ignore what I just said. Okay, the original denominator here was b minus 2, but we just turned it into this. So what was it missing? It was just missing the 2, wasn't it? So all I have to do is take 3b times 2, which is
6b.
6b. Lord have mercy. Okay, now this denominator was already 2 times b minus 2. So did this denominator change? And if the denominator doesn't change, the numerator doesn't change.
b minus 3.
b minus 3. Now from there, moving forward, all you have to do is we're going to put it back to just one single fraction. And we're going to combine the tops. So 6b plus 1b makes
7b.
7b. 6 plus 1 is 7. And then the minus 3 is just hanging out by itself, right?
Mm-hmm.
There you go. I'm so sorry about that. Not trying to confuse you guys or the people that watch my video. I'm so sorry. The restriction is b could not equal what? Yeah. Well, when we get to the part where we do the equations, we will be getting rid of those denominators. Here, it's just an addition or a subtraction problem, so we want to keep those denominators around.
Is it because the 2's outside?
No, it's because if I put a 2 here, 2 minus 2 would give me 0, and you can't have that. The 2 on the outside really doesn't affect our restriction. It's just whatever's there. But there's not a b out here. If there were a b out here, it would be a restriction. But since it's just a number, no. Okay, now look here. Do those match each other? Okay, so for our common denominator, if they don't have anything in common, don't we just write them side by side? Don't we just multiply them together? Well, man, I don't even remember what day that lesson was last Thursday. Almost a week ago. If they don't have anything in common, like this one over here did, you just multiply the two expressions together. And you don't actually even have to multiply them out. You just leave it in factored form, like you leave it as r minus 6 times r plus 1. So normally what I do is once I know my common denominator, I just go ahead and set up my two fractions and I write that down. And then I go back and worry about the tops. The top is going to require a little bit of work here. Okay, you watching? This was just r minus 6, so wasn't it missing the r plus 1? Mm-hmm. Okay, so that's what I'll end up multiplying that numerator by. Well, isn't that just distribute? Mm-hmm. So we can just do this. 4 times r and 4 times 1.
4r
4r?
plus 4.
Good. 4r plus 4. So whatever the bottom was missing, that's what we multiply the top by. And that's just 1 term times 2 terms, so we distribute. Now the second fraction is a pain in the butt. Because look up here. We had the r plus 1, which means it was missing r minus 6. Well, when I write r minus 6 up there, is that a 1 by 2? That's a 2 by 2. What do we have to do for 2 by 2s? A box problem. Yeah, so I'm going to go down here because I know I won't need all this space down here for number 14. So I'm just going to do this over to the side. It was r plus 4 times r minus 6. And whatever we get inside this box, that is the new numerator for the second fraction. What's r times r?
R squared.
And then r times 4 is 4r. When you go to the bottom row, negative 6 times r is negative 6r, and negative 6 times 4 is negative 24. Okay, so if you were to put all this stuff together, r squared is by itself. And then if we do 4r with a negative 6r, that's negative 2r, right? Because you're just adding them together.
Mm-hmm.
And then the minus 24 goes at the end. Okay, so that box is just extra work. You know, we're not going to need that anymore. We're just going to now go to our final answer. We're going to have one fraction with this as our denominator. And we just have to combine this stuff up top. R squared is by itself. It doesn't have anything to pair up with. Now what about 4r plus negative 2r?
Negative 2r.
Positive 2r. And then positive 4 minus 24. Negative 20. Here's the good news. This isn't even factorable. There are no two numbers that could multiply to make this that would add to make this. So we don't have to factor it, because if it had factored to one of these, we could simplify it like we did on the problems up here, but it won't. So this right here is your final answer. You You just leave it like that. Leave it in factored form on the bottom. You never have to multiply the bottom out. Up top, just leave it as that quadratic. Okay. Yay.
We're not putting on the restriction.
Oh, yeah. We are. We're always doing restrictions. What two numbers could not be here or here?
6, -1.
Yeah, 6 and -1. Restrictions are could not equal 6 or -1. I know Brittany said she was going to be late, but I thought she would have been here by now. Oh, she messaged me. Yes. Okay. All right, this one. We've got a 6 and a 3. Is there a way to turn this 3 into a 6? Okay, so our common denominator, we can definitely use a 6. And then if one of them's x and the other one's x squared, it would have to be at least x squared, because we could turn an x into an x squared. But this is going to be our common denominator. Okay, so again, go ahead and set up your two fractions with 6x squared on the bottom. And then so if this was 6x, isn't it just missing 1x? So we can multiply the top by an x. So if you have x times 2y, it's just 2xy. You just put all three pieces together. Okay, and then for this one, it was 3x squared, and we turned it into 6x squared. So don't we just have to multiply it by 2? So that's what you multiply the top by. And 5 times 2 is?
10.
10. So tell me something. Can we combine this stuff up top?
No.
Like, it's not really going to subtract, is it? So all you guys have to do is you just write it together like that. Like you put 2xy minus 10 over 6x squared. Here's the only thing that you would have to do at this point is this. If all three of these had an x, we could cancel an x, but they don't. If all of them had a y, but they don't. Are all of those divisible by 2? Can't we divide the three numbers by 2 and reduce it? Okay, so this would become a 1xy minus 5 over 3x squared. So you should always try to reduce it at the end if you can. I mean, there are going to be times when you can't reduce it, but if you can, you need to. And there is only one restriction. What is the only number that if I put right here would make the bottom 0?
3.
Right there.
-3.
No.
Or -1. 1.
If it's just a letter.
Oh.
If it's just a letter. What? 0. I knew you'd get it eventually. You were thinking, so if it says x plus or minus something, that's when you do the opposite. If it's just a letter, it's 0. Now, number 15, while Caden's getting caught up, 15 is synthetic division, and we've already kind of done a synthetic division problem. So you guys could probably go ahead and get at least the box set up, and then I'm going to figure out what number is synthetic division on your test. Number 15. Oh, it matches. Number 15 on your test is the synthetic division problem. Okay, so watch. We turned 6x into 6x squared, so it was missing an x, right?
Yeah.
So that's what I multiplied the top by. So 2y times x is just 2xy. And then this was 3x squared, so I had to multiply it by 2 to turn it into this, so I multiplied the 5 by 2. Okay, the only thing is the top, none of them combined. So only thing I had to look for was, did all three numbers have something in common? And they could all be divided by 2. So I just reduced it at the end. All right, synthetic division. Look, 1, 2, 3, 4 terms. So just like before, we're going to make 4 columns, and then there's always 3 rows. 1, 2, 3, 4. So we've got a 1, a 12, a 31, and a 4. And the first number always drops straight down. Now, the k plus 3 out here, that's the number we use over here, but it's not positive 3. We always make it its opposite. Because what you're supposed to do is you're supposed to set that equal to 0 and solve it, and that's the number we use out here for the multiplication. So remember, we do bottom number times the negative 3.
So it's negative 3.
And then you add going up and down. And it'd be 9. And then you do the 9 times the negative 3.
Negative 27.
Negative 27. And 31 minus 27 is 4. 4 times negative 3 is negative 12. And the remainder will be negative 8. Now, if you were not here the day we did synthetic division, I feel like most of you were, but if you were not, the way we wrote our answer, this 1 represents not k to the third, but k squared, because remember, we always drop 1. So then the 9 would be the k term. So I have 1k squared plus 9k. The 4 would be the constant. So watch. Our remainder, if it's negative, you put a minus sign with a fraction bar right next to it. If it were positive, this would be a plus sign with a fraction bar next to it. Okay, 8 goes up top. And then remember this right here? That's what we were dividing by the whole time. That goes on the bottom. That right there is your final answer. And just trust me when I say I used to have to teach division 2 ways, synthetic and long division, and long division was horrible. So trust me when I say this is so much easier than if you guys actually had to do long division and get that kind of answer. Long division is a pain. I'm not doing it right now.
Oh, it's that bad?
All right, so then I think the next page is where we do those equations. So there's going to be quite a bit of work on this next page. Quite a bit. 19 and 20 will be easy, and even the back page will be super easy. It's just really these 3 are going to take some work here. Let me see which ones they match up with. So the addition is number 12 on your test. And then this one's also addition. So I guess this could go with number 12. There's only one addition on your test and one subtraction. So then the subtraction problem is number 11. Now keep in mind, just because like the one on your test may be easier than this one, but it's just subtraction. That's why I'm telling you it's like the one on your test. Okay, it doesn't necessarily mean that you'll have like the exact same type, but it'll be similar. Okay, we need to establish a common denominator. So look, r squared, r squared. Could we turn the r into an r squared? Just by multiplying it by an r, right? Okay, so r squared is our common denominator. Now this is where, since it's an equation, whatever your common denominator is, that is what we're multiplying all the tops by. So I'm going to squeeze in a times r squared because watch what happens. This is great. This r squared, one of those r's would cancel this one, right? Just leaving one behind. So watch. This r would get multiplied by the 5r plus 6. I could have distributed, but I'm just writing it out so you guys can see what I'm doing. Now look at the middle fraction. Wouldn't r squared cancel the r squared on the bottom? Just leaving behind a 1? And then wouldn't this r squared cancel this r squared? So it just leaves the r squared plus 5r plus 6. So by multiplying all of our numerators by the common denominator, it clears the denominators out. Bless you. The denominators are no longer there. So this is just a nice quadratic equation that we're going to solve. We need to distribute here. What's 5r times r?
5r squared.
5r squared. And then 6 times r is 6r, and we have a plus 1. The right side is just going to stay the same. Now, since I see r squared, doesn't everything have to come to the same side? Okay, so it would make sense to bring these three this way. Okay, so I'm going to subtract 1r squared. That'll cancel that one. I'm going to subtract 5r, which will cancel that one. And then I'm going to subtract 6. So now the right side will say equals 0, and we can just combine like terms over here. 4r squared plus 1r minus 5. That's our quadratic that we're going to factor. Okay, can you guys do an asterisk for that?
Yeah.
Okay, go ahead and set it up. I'm going to try to squeeze all this in here. Let's see, negative 20 and positive 1. What do you guys think for 20? Negative 4 and positive 5. So the 4r plus 5 does not reduce. But this one, wouldn't that reduce to 1r minus 1? So at least one of them we can, like this one, we can just go straight to our answer. R would be positive 1. Now the 4r plus 5, I'd write that one out. Because that's a two-step. Now, I always leave my answer as a fraction. So I subtracted 5 and then divided by 4. So I left mine as negative 5/4. You guys could do the division, and it would be negative 1.25. Well, I'm just saying, you guys, you might just type it into a calculator. And the only thing we need to do is look back at what our restriction is, because remember, sometimes if we get two answers, if either one of those had been our restriction, we'd have to cross it out. Well, if all of my denominators were just r or r squared, what's the only number that it could not equal? No, what's the only number? 0? 0? Yeah, because if you had a 0 right there, that would make your denominator 0, and that's not allowed. So this was the only restriction. Well, did we get a 0 as our answer? No. So it was fine. The two answers that we got, positive 1 and negative 5/4, those are both acceptable answers. Okay, this next one over here, k minus 6, k minus 6. These two have a k in common, and wouldn't that leave k minus 6? Whenever you can factor one of the bottoms or two of them, you have to factor the denominators, because that's the only way you can figure out what your common denominator would be. So as far as common denominator goes, look, they all have a k minus 6, so clearly we're using k minus 6 as part of it. Well, what other piece do I need to include?
The square and the other k.
I have to include this k, don't I? So this right here is your common denominator. Okay, now look, for space, normally what I would have you do is I'd have you guys write both of these next to the 2, next to the 5, next to the 1, and then we would show what would cancel. But we can talk this out. This k minus 6, if I had it up top, would cancel this k minus 6, right? Okay, so if that cancels, the only thing left is the k up top, yes? Okay, so I have a 2k. Then I have an equal sign. This fraction right here, same thing. The k minus 6 here would cancel this k minus 6, leaving behind just the k with the 5, which is 5k. And then this one over here, wouldn't both of those cancel both of these? So doesn't it just leave a plus 1? That is a super simple equation to solve. All I have to do is bring these k's over and then do division, right? So how would I move 5k over? Yep, subtract 5k from the 2k, and we get negative 3k equals 1, and then just divide by negative 3. And just by looking at it, you can see it's a fraction. It's negative 1/3. Or if you had typed it into your calculator, you would get negative 0.3 repeating. So let's see what our restrictions were. I always forget to do that in the beginning before I start crossing stuff out. K could not be 6, right? Because if I put a 6 there, 6 minus 6 would be 0. And then since there was a single k right here, that couldn't be 0 either. So those were our two restrictions. But our answer was negative 1/3. So our answer was fine. And we only have one more like that. We're just going to work through a break so we can just get this done and then you guys can go, okay? All right, so now look here. We have an n minus 5, we have an n plus 5, and then we have n squared minus 25. This is difference of squares. What would that factor to? N plus 5 and n minus 5. That's nice because both of these already are there. We've got an n minus 5 there and an n plus 5. So our common denominator for this one, isn't it just both sets of parentheses, these two? N plus 5 and n minus 5. That would be our common denominator. So now again, I need you guys to talk this through with me, because there's no way, especially on this paper, I cannot fit both of these up top. I just can't. So this n minus 5 would cancel this one, leaving the n plus 5, right? Okay, so look, I'd have n minus 1 times n plus 5. That will be a box problem. I'm just not going to do it yet. I'll do it once I've set everything up. Now, these two would cancel these two on the bottom, right? So the top wouldn't change. It'd just stay n squared minus n. And before I do anything else, can you guys do this? Since that's a minus, change that to plus -1. Trust me, you'll want to, because we're going to have to distribute that -1 here in just a minute. This n plus 5 would cancel this n plus 5, leaving behind just the n minus 5. So I have a -1 that I'm going to multiply by an n minus 5. You could put plus -1. I just put it back to a minus sign. All right, so let's work this stuff out. This side's easy. Let's just go ahead and knock this side out real quick. If we distribute here, -1 times n is -1n, and -1 times -5 is +5. I am going to go over to the side and do a box for the n minus 1 and the n plus 5. What does that give us? N squared minus 1n plus 5n minus 5. Okay, so the n squared goes first. And then if you do 5 minus 1, that'd be a plus 4n, and then minus 5. This really isn't too bad, because watch what happens. Watching? N squared plus 4n minus 5 equals n squared. I'm going to put these two together. That'd be minus 2n. So since I have a squared on the left, don't I need to bring everything over with that? Okay, but watch. If I get rid of n squared, isn't my n squared gone? Like, we don't have n squared anymore. We just have 4n minus 5 equals -2n plus 5. You know, a lot of times that doesn't happen. If we have a quadratic on both sides, normally when we bring it over, there'd still be an n squared term, and we'd have to do the asterisk. This one just worked out that the n squareds canceled each other. So now, this is what I would do. I'd add 2n, and then I'd add 5. I'd bring the n's this way and the 5 that way. So I'd add 2n, giving me 6n minus 5 equals 5. So this is right there. This problem's all over the place, isn't it? And then I would add 5 to both sides. So 6n equals 10. Divide by 6. Yeah, the only bad thing is 10 over 6, you can reduce that. Cut them both in half. 5/3. Yeah, again, I think some of you guys would probably type that into a calculator and be 1.6 repeating. But there's our answer. And our restriction, if you just look back at the common denominator, wouldn't our restrictions just be 5 and -5? Yes, Melissa, they sure would. Because we had m plus 5 and n minus 5, so those would be our two restrictions, 5 and negative 5. That is a big problem there. I know. Trust me. Okay, the word problems. 19 and 20 are 13 and 14 on your test. Let me just, yeah, and they're in the same order. So number 13 on your test is asking how long it would take if they worked together, and number 14 will ask for somebody's individual time. Okay. So this is how we set it up every time. Remember, somebody's fraction plus somebody's other fraction is one total job. That's how it works for both of these. So I always get it just set up from the get-go. Then we're just going to start filling in. If you are looking for how long it takes them together, that's the top, and we always just use the letter T, and they should both be the same. Okay, so then it says somebody did, let's see, 14 hours by themselves and 15 hours by themselves. Okay, how do we find our common denominator? Yeah, it is 14 times 15. 210. Okay, so this is all you do. Times 210, times 210, times 210. Because then 210 divided by 14 would leave the 15 behind. And the 210 divided by 15 would leave the 14 behind. So you end up with just 15t plus 14t equals 210. $210 divided by 14 is 15. And 210 divided by 15 is 14. Okay, we just add these. What's 15 plus 14? 29t equals 210, and then just divide. So like 7.2, and it was measured in hours. So if they were to work together, it would only take them 7.2 hours. You know, if they work together, it should take less time than if they had worked alone. So then for the other problem, working together, it would take 4.74 hours. So the 4.74 is how long it takes them together. So that goes up top, and it would be on top of both fractions. Let's see. Trevin by himself is 9. And then, I don't know, Sumali or something. We're looking for that time. So you just put the t on the bottom. This common denominator is even easier. 9t, right? 9 times t is 9t. So that's our common denominator. And just like before, we're going to multiply every piece by that 9t, because then stuff will cancel. We get the 9's here to cancel, leaving behind 4.74t. Now in the middle, it's not the 9 that cancels, it's the t. 4.74 times 9 is 42.66. And then over here would be 9t. So since our t's are on opposite sides, we don't add them together. We're going to bring this one over using subtraction, right? Yep. And then we just divide by 4.26. Should be just over 10. 10.01. That would be hours. That's if Sumali worked by, I'm going to say, herself? I don't know. We've only got 3 problems left, and these are some of the easiest ones on the whole thing. 10.01. Alrighty. Absolute value equations. So these go along with 16 through 18. So the last 3 of your test go with the last 3 of the review. Okay? All right, so absolute value equations. That was the very first thing we did in this unit. So it's been a while, but you cannot solve this until this expression is by itself. So if there's a plus 9, how do I move it? Okay, go ahead and subtract 9 from both sides. The absolute value of negative 4p equals 8. That's what we get. Okay, now that our absolute value symbols are isolated, this is where we break it to 2 separate equations. The first equation we write looks just like this, just no bars. Okay, so first equation is negative 4p equals 8. Now the second equation looks like this side over here is the same. The expression in the bars never changes. What changes is the answer.
Negative 8.
Yeah, we make this one a negative 8. Because if you think about it, the numbers that have an absolute value of 8 are positive 8 and negative 8. So that's why we set them equal to both. And now you just solve them. Just divide by negative 4. And those are our 2 answers. We get a negative 2 and a positive 2. And don't just assume that all of your final answers will be opposites of each other. That's not very typical. Like, that doesn't happen very often. This one just worked out that way. But don't assume that if one of your answers tomorrow is 10, don't assume that the other one's going to be negative 10. You got to do the work. This one. We got 2 numbers we got to get rid of. This one here and this one here. How do I move a plus 9? Okay. So all I've done so far is subtract 9.
Equals 18.
Mm-hmm.
So then don't you minus 9 on both sides?
Not minus. That means multiplication since they're side by side, so we're going to divide by that 9. Now that the bars are isolated, now you can separate. First one looks just like it. 6n minus 8 equals 2. And then the second one, 6n minus 8 is the same, but we change it to -2. So we add 8 and divide by 6 on both of them, right? Sometimes one of them will be a whole number and the other one will be a fraction, and that's completely fine. So we get a 1 there. So I would have just reduced it to 5/3, but it's 1.6 repeating. Yep. And the graph, pretty simple. It's not bad. You might not have, but we do it very similarly to how we did quadratics. Yeah, the +3 here stays the same, and it is the y. So I know that. Now the number that's inside the bars with x, if there were a number, like let's just say it said x minus 1, you'd have to make it its opposite. The x always becomes the opposite, but if there's not a number with it, what is it? 0. Yeah. Now on your test, there's a number with it. So if it says x minus 2, you're going to turn it into +2. If it says x plus 2, you'd make it -2. The x, you might want to write that on there. Whatever number is paired with x would become its opposite, and whichever one's outside is y, and it stays the same. Just so that way you know, remember that for tomorrow, okay? So go ahead and plot 0, 3. So it's right here. Right there. And then typically we have like a T-chart, and you guys would have, like you'd put the vertex in the top one, and then don't we usually just pick 2 numbers to the right or left? We usually pick the 2 to the right, so like 1 and 2. And all we have to do is plug them into the original. So watch. Over here I'd have -3, and inside the bars would be my 1, +3 on the outside, and -3 with the 2 on the inside +3. You know, we can't type this into the calculator because it's absolute value, but you guys, we could do this.
So the absolute value of 1 would be 1, times it by -3, right?
Mm-hmm.
Which would make it -3, and you add the 3 to it, and
Yep.
then the second one, absolute value would be 2, and by -3, 3 to that, which would make it -3.
Mm-hmm. Yep, so I'm just doing this step by step. Absolute value of 1 is 1, times -3 is -3, plus 3 is 0. Absolute value of 2 is 2, times -3 is -6, and -6 plus 3 is -3. So then you guys could plot those. You could plot 1, 0, and 2, -3. And then can't we just mirror them like we did with quadratics? So this one would mirror to -1, 0, -2, -3. Yep.
And is this the one where you have to do it with a V?
Yeah, absolute value will always be a V. So you guys should, I mean, I would use a ruler usually. You should put a ruler down because those will connect. With the quadratic, we couldn't because it was a curve. But with absolute value, it's going to be a V. Okay. Now there is one extra problem on your test that we never really discussed. And it asks you basically like, what does it mean when they say, like, check for extraneous solutions. So we're gonna write something here. Because every time in the directions, if it says, don't forget, check for extraneous solutions, that is the type of solution that if you got it as one of your answers, like remember every time we had a quadratic, we could get two answers. Sometimes we had to cross some of them out, like if it made it false. So extraneous solutions are solutions when if you plug a solution into the original problem, and you get a false statement, if you get a false statement or a 0 as the denominator, it is extraneous. Okay? I never talked about number 6, but that's what number 6 is all about. They're going to ask you about extraneous solutions. Okay? So extraneous solutions are just those solutions that if you plugged them into the original equation, if you got a 0 on the bottom of a fraction, you had to cross it out. If it makes the statement false, got to cross it out. Okay? And that is the end of your review. And officially the longest video I've ever made.